start. Okay. Good. Hamza, am I audible?
Yes, sir, you're audible.
Okay, so in the last class we have taught studied about the finding molasses present in 500 centimeters solid. It's a very solid on normality based
Sir,
on.
your voice is breaking. Sir, there is a delay.
Hamza, still
Sir, your voice is breaking.
delay.
Yes, it's still there.
Okay. Is my voice breaking now?
Yes, sir, it's still breaking.
Now, Hamza, recording it. Is my voice Hamza?
Yes, sir.
Okay, please do this question. Am I audible now?
Yes, now it's clear. I
Okay,
can
thank
see
you.
the question, yes.
Okay, please solve this question and let me know if you need any explanation. Fatima, am I audible to you?
Yes, sir.
Okay, so in the previous class, you just left in between the classes. I had taught about normality. Do you know normality? Fatima, can you solve this question?
I try, sir.
Okay, please try it and let me know if you are unable to solve it.
So that's 490 or 49?
It's 490 gram. Fatima, if you need any type of explanation in this question, please let me know.
Sir, shouldn't it be
Yes,
500 ml?
it's not necessary. 500 centimeter cube is also centimeter cube is also a unit of volume, right?
Um,
So you should know. Basically, you should know about 1 ml is equal to 1 centimeter cube. So you can easily convert 500 centimeter cube. That means 500 ml.
ml, yes.
Now you
Okay.
can easily convert it into liter.
Yes.
Very good. Fatima, do you know the formula to calculate Fatima?
Yes, sir.
Do you know how to calculate normality? Do you know the formula of normality?
Is it number of gram?
Number, very good. Number of gram equivalent of upon volume of solution in liter. This is the formula for calculating normality. Also, you can see volume of solution in liter is given here. Volume of solution is given, which you can easily convert it into liter. What we need to calculate is number of gram equivalent of solute with the help of given mass. Now, do you know how to calculate number of gram equivalent? In the previous class, I have given you a formula. Number of gram equivalent is equal to given mass upon equivalent mass. Given mass upon equivalent mass. Now you can see given mass is given, that is 490 gram. But what about equivalent mass? Then another formula comes about equivalent mass. Equivalent mass, molar mass upon X. X is valence factor or N factor. Molar mass of what? H2SO4, which is 98, and X is, since it
98.
is acid, and this acid H2S, yes, this acid H2SO4 can give 2H plus. That's why X has a value 2. So we got equivalent mass, that is 49. So going to put the value as here 49. You can get 10 gram equivalent. That means number of gram equivalent is just calculated, that is
10.
10 gram equivalent. Now going to put the value 10 gram equivalent here, and the volume of solution in liter here. Normality is equal to number of gram equivalent, that is 10,
10 by
and volume is
0.1.
500 centimeter cube.
0.5.
Yes, the volume of solution is 500 divided by 1000. So you can see, I'm going to just calculate it. It will be like this. Only two zeros will be cancelled. This, wait a minute. You zeros will be cancelled, and now I can write 10 by 5 by 10, and this 10 will be in numerator, comes to numerator, and it will be 10 into 10 divided by 5. So 5 to the 10. So normality is basically
20.
20n. 20n. Fatima, is that clear to you? Hamza?
Yes, sir.
Yes, sir.
Very good. Very good. Please write it, and then we will start the new topic of class 12, that is solubility. This all concentration term we have already discussed in class 10. Sorry, 11th. Please let me know when you are done with this. Done. Fatima or Hamza?
Yes, sir.
Okay, thank you, both of you. Now coming to the next topic, which is solubility.
Sir, your voice is breaking again.
Solubility. What? Still my voice is breaking?
Now it's clear. Okay.
Okay. That's why because of the low internet connection, I just switched off my video so that the voice should be clear. Now see, solubility. What is solubility? Basically, in a specified amount of solvent, the maximum amount of solute that can be dissolved in that solvent is called solubility. We can take example like just take 1 liter of water and take sugars. The maximum amount of sugar that can be dissolved in that water is called solubility. So I'm going to define it. The maximum amount of solute dissolved in a specified amount of solvent, a specific solvent at constant temperature, at constant temperature. This is called solubility. Basically, solubility can be expressed in like gram per liter or kg per liter, or also mole fraction. Henry's defines solubility in terms of mole fraction. Is that clear to all of you? Hamza and Fatima.
Yes, sir.
Thank you. Now see, the next topic is factors on which solubility depends. Factors on which solubility depends. So there are major three factors on which solubility depends. The first one is nature of solute and solvent. The second factor is temperature, and the third factor is basically pressure. So solubility depends on nature of solute and solvent, temperature and pressure. So I'm going to discuss how solubility depends on the nature of solute and solvent, how solubility depends on temperature and pressure. So first of all, write all these topics and then we will start discussing nature of solute and solvent. Please write it. Hamza, do you have any doubt in this solubility?
What, sir?
Do you have doubt any solubility? Do you?
No.
Okay, please write it and let me know if you are finished with this.
Okay, sir.
Both of you done with this?
Done, sir.
Okay, Hamza, are you done with this?
Yes, sir.
Okay. See, I'm going to explain how solubility depends on nature of solute and solvent. Nature of solute and solvent. So first of all, I'm going to discuss solubility principle. Generally, what happens or what is the solubility principle? Solubility principle says that like dissolves like dissolves like. That means a polar compound is soluble in polar solvent. That means I'm going to write it. Polar solute is soluble in polar solvent. Polar solvent. Do you know what is polar, Fatima and Hamza? What is polar compound? Any one of you?
No, sir.
See, polar means basically charged molecules. Any solute that is charged and any solvent that is charged is called polar solute or polar solvent, or you can call it polar compound. So basically, if you are going to
Charge
see,
means plus or minus, both, right?
Yes. Charge, that means uh, plus or minus. This is let's say NaCl. NaCl, how does it exist? On Na it is plus and NCl it is minus. And take an example of polar solvent, that is H2O. H2O is a covalent compound, but you know that. Do you know oxygen is very highly electronegative element? Electronegativity. First most electronegative element is fluorine, and then oxygen, and then nitrogen. So basically, do you know what is electronegativity, Hamza and Fatima?
Yes, sir.
Electronegativity. Do you know what is electronegativity?
Yes, I kind of remember it. Um,
Okay, very good. What about you, Fatima? So basically, Hamza, very good. Electronegativity is basically it is property to attract or withdraw, attract, or you can say withdraw bonded pair of electron, bonded or shared pair of electron, shared pair of electron. So you you should know that hydrogen has its own electron in bonding position like this, but oxygen is very electronegative element. So what will oxygen do? Hydrogen's electron will be slightly displaced towards oxygen. So oxygen will have delta negative and hydrogen will have delta positive. In the same way, this hydrogen will also have delta positive, and for this positive charge it will be delta negative. So basically H2O is polar solvent. So in order to dissolve in H2O, that is polar solvent, a solute must be polar solute. Is that clear, everyone? Hamza, Fatima?
Yes, sir.
Okay, thank you. The next is basically non-polar solute. It's soluble. It's soluble in non-polar solvent. That means a compound which is uncharged. You can see CCl4 is non-polar, which is solid. We are taking CCl4 as solid, and benzene, which is also non-polar solvent, which is also non-polar, and that is solvent. So CCl4 is dissolvable or soluble in benzene because CCl4 is non-polar and benzene is also non-polar. So solubility principle, what it says, like dissolves like, that means polar solute will be dissolvable in polar solvent and non-polar solute will be dissolvable in non-polar solvent. I think it's clear to you, both of you. If you need another explanation, please let me know. Hamza,
yes, sir.
do you need any other explanation? Another
No, sir.
explanation of this? Okay, please write it and let me know if you're
Yes,
done
sir.
with it. Are you done with this, Fatima?
Almost.
Okay, okay. Let me know, Hamza, when you are done with this.
Yes, done.
Very good. Fatima, are you done with this?
Yes, sir.
Okay, thank you. The next factor is basically temperature. So see how temperature affects solubility. Before starting this, we just have to know first whether the solution we are making is endothermic or exothermic. So I'm going to explain it. If dissolution process, if dissolution process is exothermic, then with rise in temperature, then with rise in temperature, solubility decreases or increases, that I will explain. And if dissolution processes and if dissolution processes and then with temperature, then with rise and is in temperature, what happens with solubility? I am going to discuss. So see, do you know what is exothermic process and what is endothermic process? Both of you, Fatima and Hamza.
Yes, sir.
Yes, sir.
So basically, you know that exothermic process is the process in which heat is coming out. Heat is coming out. That means this process is already have a lot of heat. That's why it is releasing heat from the solution. That is called exothermic process. Audible to both of you.
Yes, sir, you're audible.
Now see, exothermic process is the process in which heat is coming out. Our endothermic process is heat is given to the system or the solution. Now, I will explain Hamza and Fatima.
Sir, your voice is not coming.
Okay. Is the screen visible?
Okay, now it is, yes.
Hamza, is the screen visible?
Yes, sir.
And now what I was asking is, if you are going to increase the temperature indirectly, you are increasing heat energy. Yes or no? Please answer me. Hamza, Fatima, Fatima, Hamza.
Yes, sir.
So see, in exothermic process, since it is giving heat out, that means it doesn't require any heat. And if you are going to increase the temperature, that means you are giving heat energy indirectly. So with increase in temperature for exothermic process, solubility decreases. Solubility decreases. And if the dissolution process is endothermic, that means it requires heat. And if you are going to increase the temperature, that means indirectly you are giving heat energy. That means it is favorable condition for this process, so solubility increases. So please write it and let me know if you need another explanation. Hamza and Fatima. Hamza, do you need another explanation?
No, sir.
Okay, please write it and let me know. We can also write it for exothermic process, delta H less than 0. If you are going to increase the temperature, solubility decreases. And here delta H for endothermic process in class 10th, 10th or 11th, you have learned that endothermic process change in enthalpy is greater than 0, that is positive. And if you are going to increase the temperature, solubility also increases for endothermic process. Hamza, please write it and let me know if you are finished with this. Hamza, are you done with this?
Done, sir.
Fatima. Okay, thank you, Fatima. Hamza, let me know if you are done with this.
Yes.
Okay. Third factor comes out to be pressure. So generally, when we mix solid in liquid and when we mix gas in liquid, this gas in liquid we will study after this topic in Henry's law. in Henry's law, we will just study. But this solid in liquid, I'm going to explain how the pressure depends on solid in liquid, in solid in liquid. So basically, there is no effect. There is no effect on solubility of solid in liquid because solids are already compressed. So basically, you know that solids are already compressed. So there will be no effect of pressure if you are going to dissolve solid in liquid. But there will be effect in gas and liquid that we will study in Henry's law. But there is an important question, that is why aquatic animals are comfortable in cold water than hot water. Do you know why does this happen? Aquatic animals are more comfortable in cold water or in winter as compared to summer or in hot water. Why? Because dissolution of gas in liquid is exothermic process. And in exothermic process, when temperature increases, solubility decreases. That's why it is not comfortable for aquatic animals to live in hot water than cold water. So I'm going to explain it. Dissolution, write it. Dissolution of gas in liquid is an exothermic process. Is an exothermic process. As temperature increases, solubility decreases. Basically, in hot water are less soluble. That's why it is they are uncomfortable in hot water. Please write it. Let me know if you are done with this. Fatima and Hamza, are you done with this?
1 minute, sir.
Okay, take your time.
Done.
Very good. Hamza, are you done with this?
Yes, sir.
Okay. Now, this is basically the factors on which solubility depends. So I'm going to tell you again that this pressure when solid in liquid will have no effect because solids are already compressed. But this is very important. Why aquatic animals are comfortable in cold water than hot water? because dissolution of gas in liquid is an exothermic process, and since in hot water temperature will be more, so solubility decreases. So oxygen solubility of oxygen in water is not that much. That's why they are uncomfortable in hot water. So I'm going to take another topic, that is Henry's law. See, Henry's law. What does Henry's law say? I'm going to first write it and then I will explain it. Please write with me. I already told you that Henry's is about gas in liquid. Gas in liquid. So according to this law, write with me, please. According to this law, solubility of gas in liquid is directly proportional to is directly proportional to partial pressure of that gas above liquid surface. Above liquid surface. It is very easy to understand with the help of day-to-day life, like cold drink, liquid surface. Now you all have drink a cold drink. Now see, this is the bottle of cold drink in which uh, these are all liquids cold drink. When you open the bar, this when you opened it, there is a feeling of gas. Basically, the this in between this and this liquid, there is gas filled in this cold drink. So basically it is talking about this. Henry says that solubility of gas in liquid, this gas solubility of gas in liquid is directly proportional to the partial pressure. That means this gas is applying a pressure on the surface of the liquid. They are directly proportional. So I'm going to write it another form, like solubility of gas in liquid is directly proportional to partial pressure of gas above liquid surface. Partial pressure of gas above liquid surface. This gas that applying pressure on the liquid, that partial pressure is directly proportional to the solubility of gas in liquid. And I already told you that this solubility, according to Henry's, he defined solubility in terms of mole fraction. So we will talk about it soon. But first of all, if this quantity is directly proportional to this quantity, that means this quantity is directly proportional to this. So I'm going to just reverse it. Partial pressure of gas above liquid surface, directly proportional to solubility of gas in liquid. So I just reverse the sentence. If 1 is directly proportional to 2, that means 2 is directly proportional to 1. Again, partial pressure, I am going to denote it by P, directly proportional to solubility, that is defined in terms of mole fraction. And this is basically mole fraction of gas. And this is partial pressure of gas. We are talking both about a gas, partial pressure of gas above liquid surface. And if you're going to remove this proportionality sign, we will get a constant, that is kh. And this is known as basically Henry's constant, that will be given in the question. Henry's constant, which depends on nature of solvent, gas. Please read it, and if you have any doubt, please ask me. I will explain it again. Do I need to slide it up? Hamza, Fatima. Hamza,
Yes, sir.
are you done with this?
Yes, sir.
Okay. So see, I'm going to explain it again. Fatima, are you also done with this? Henry's law. Basically, solubility of gas in liquid is directly proportional to the partial pressure of that gas above liquid surface. Let's take an example of cold drink bottle, and you know that this is liquid, and between this point and this liquid point, there is gas filled in it. So, what Henry say, solubility of this gas will be directly proportional to the partial pressure of this. So, we write solubility of gas in liquid directly proportional to partial pressure of and is directly proportional to 2. That means 2 is directly proportional to 1. So, we just reverse it. Of liquid is directly proportional to solubility of gas in liquid. Now, partial pressure of gas, that is represented by P. P is directly proportional to X. That means mole fraction of gas in liquid. And for removing this proportionality sign, use a constant that is called constant KH and depends on the nature of solvent and gas and also temperature. So this is the formula for Henry's law. Now we are going to plot a graph and please be focused. The graph is between partial pressure and mole fraction. Mole fraction, and here it is on y-axis. It is partial pressure. So we know that according to Henry's law, pressure directly proportional to mole fraction. So the graph will be a straight line like this. So this is the graph between partial pressure or mole fraction according to Henry's law. Is that clear? So P is equal to, we just saw formula, KH is equal to P is equal to KH into X. So for the value of KH will be equal to P upon X. Zeta, we also called this X as zeta. Now see, can anyone tell me unit of KH? Unit of KH will be equal to unit of pressure. Why does it so? Unit of pressure. Why does it so? Because we know that this X mole fraction is less, and whatever is the unit of pressure, that will be the unit of KH, that is Henry's constant. So there will be formula for KH, that is P by X. Now come to this graph, we will talk about slope. Slope is denoted by M, and we know that slope is, how to calculate slope? Slope is calculated by tan theta. And tan theta is basically, from class 10th, you have learned about tan theta is equal to perpendicular upon base. Perpendicular upon base. So if you have theta here, so what will be the perpendicular? This will be perpendicular, which represents partial pressure, and this base which represents fraction. So basically this is P upon zeta X, and this value is equal to, you can see by X is equal to, so P by is equal to KH. What I want is that from this graph, I conclude that slope of partial pressure of partial versus mole fraction graph gives constant, gives Henry's constant. So it's clear from the graph between partial pressure and mole fraction, and the slope of this graph gives Henry's constant. Is that clear? Hamza,
Yes, sir.
Fatima. Okay, please write it and let me know when you are done with this. Fatima, Fatima, do you have any problem in this? Okay, please let me know when you are done with this. Please let me know. I'm going to give a question on this Henry's constant. Then we will move to the next part. That is vapor resistance. I'm sorry with this. Hamza, Fatima, are you done with this?
Yes, sir.
Okay, thank you. Hamza, are you done with this? Okay, I'm going to give you a question. The question is basically, okay, thank you, Hamza. If N2 gas is water at 90 Kelvin, how many moles of N2 gas, how many moles of N2 gas would dissolve in 1 liter water? Assume N2 exerts a partial pressure of 0.987 bar, given that Henry's law for N2 at 293 Kelvin is 76.48 kilo bar. Please write the question and let me know if you can do it or not. This is exactly based on the Henry's law and its formula. You can easily solve it. And if you have any doubt, please let me know. I will explain.
Sir, I don't know how to solve this, sir.
Okay, no problem, Hamza. Am I audible to you clearly?
Yes.
Okay, see. It is given that N2 is bubbled through water at 293 Kelvin. How many moles of N2 gas would dissolve in 1 liter of water? It is given that what we need to calculate, number of moles of N2 we need to calculate. And basically N2 gas is dissolved in water, and water has a volume that is 1 liter is given. And as assume that N2 exert a partial pressure. Partial pressure is given. Partial pressure of N2, that is equal to 0.987 bar. Also, it is given that KH has a value that is equal to 76.48 kilobar. This has value kilobar, which can we easily convert it into bar, that is multiplied by 1000, and it will be 1.0. Now going to apply Henry's law. According to Henry's law, I can write P is equal to KH into zeta. This is mole fraction of gas, and this is pressure. Because I already told you that this partial pressure is for gas and mole fraction is also for gas. Now partial pressure is given as 0.987 and KH has the value that is 76480 into mole fraction of N2. Again, first of all, I'm going to find fraction N2. So for the mole fraction N2, it will be 0.987, 0.9 divided 76480, and it will be, if you are going to solve it, it will be approximately equal to 1 into 10 raised to the power minus. So what we just calculated is mole fraction of N2. Now you know that mole fraction of N2 will be equal to we have a formula, number of moles of N2 upon 2. So with there is H2 in the container, with N2 there is H2 according to the question, and you know this is given. This is we need to calculate. And what is the value of number of moles of H2O? So it is given that volume of H2O, that is given as 1 liter. Volume of H2O is 1 liter. This will be written as 1000 ml. 1000 ml. Now we already know that H2O, density of H2O is basically 1 gram per ml. So with the help of this density, that is not given. Basically, we should know what is the density of H2O, that is 1 gram per ml, and volume of water is given, that 1 liter is equal to 1000 ml. Density is equal to upon. So for the mass of water, for the mass of water into 1000, so the mass of water is 1000 gram. Mass of water 1000 gram. So we can easily calculate the number of water. You can see number of moles of water will be, and mass, that is 1000 gram, upon molar mass, that is 18. So if you go and divide it, it will be 0.5 moles. Now from this, and we are going to calculate it. It is very easy. It is given, we calculate this value is equal to this much. So I'm just going to put the value 1.2 into 10 raised to the power minus 5. Equal number of moles to need to calculate, and here number of moles of N2 we need to, number of N2, the moles of water we just calculated as 55.2 moles. In Henry's law, generally we have to neglect this value. We have to neglect this value because this water molecules are very, very large than this gas molecule. So in order to add a very, very small amount with number in a very large number, we can easily neglect it. And after neglecting it, you can see what I get is 1.29 into 10 raised to the power minus 5 will be moles of pond 55. So here you can get number of moles of N2 will be 1.29 in 10 raised to the power 5 into 55.5. This is the number of moles you will get. Please write it. Hamza.
Yes, sir.
So should I slide it up? Please do this from here. Fatima, do you need another explanation of this first?
No, sir.
Oh, thank. Sorry, I couldn't turn on my camera because network connection and background. Let me know you're done with this.
Yes, sir. So done.
You're also done? Okay. Now the next topic is basically vapor pressure. For all with okay. What vapor pressure? What is vapor pressure? Basic pressure exerted by vapor or water vapor is called vapor pressure. For water, it is vapor. Fatima, is the screen visible to you?
Yes,
No.
sir.
Okay, now it is.
The pressure exerted by vapor called vapor. So body pressure exerted by is called vapor pressure. I'm going to give an example which is very important. This is a container in which water molecules are there. Water molecules. So see, and you are giving it to the container evaporate or make some vapor. The molecules are called surface molecules and the molecule. Question arises here is that which molecule evaporates, the molecules or the molecules? Is there any answer of this? Which molecule evaporates, the surface molecule or bulk molecule? Am I audible clearly? Hamza,
Yes, sir.
molecule is going to heat this container. There are two types of molecule in this container. The surface molecule is called surface molecule. On the surface, they are called surface molecule, and below surface, all the molecules are called bulk molecules. So basically, which molecules evaporate, surface molecule or the bulk molecules? So I'm going to explain it in evaporation.
Sir, the surface
During
molecules, obviously,
evaporation,
right?
in evaporation, surface molecules. Yes, yes, surface molecules evaporates. Surface molecules evaporates. And why does it so? Because they have, that means surface molecules have kinetic energy, higher energy, and also force at low force of action. Basically, surface molecules, there are low force due to higher kinetic energy. That's why surface molecules evaporate. So please write it. Is the screen visible? Hamza, Fatima.
Yes, sir.
Okay, are you done with this? Are you done with this? Fatima,
Yes,
are you done
sir.
with this? Okay. Okay, Fatima. So this is it for today. There will be test of both of you up to this topic, up to
Sir,
10
what?
next. There will be test. Okay, you will get the
When?
test paper coming week before Saturday. You will
Okay.
get on your